for this activity, we're going to look at graphs of antiderivatives, which often appear in multiple choice questions, and also finding a function rule given a rate of change and a boundary condition. Now, a boundary condition is just additional information that allows you to find C, a constant of integration. So the example we're going to have a look at is find the rule for the function f if f dashed of x is 4x cubed minus 6x plus 2, and the graph of f passes through the point -1, -5 on 2. Okay, so I already have f dashed of x graph, and what I'm going to do is on the same page, I'm also going to graph the antiderivative. So f of x should be an antiderivative of f dashed of x. So I'm going to use the shift plus shortcut to get the template, and I already have f dashed of x in f1, so f1 of x is f dashed of x, and I'll tab across the x, and I get an antiderivative graph. But note that this is not the antiderivative I want, because if you notice at x equals -1, the y value is -4, so in fact it doesn't pass through the right point. And let's go into a calculator page and investigate what's going on. Okay, so I want to solve for C in the calculator application, and I want to find what value of C will have the graph passing through -1, -5 on 2. So I'll start once again, shift plus, and f1 of x, tab across the x, and we see that it returns the value of the antiderivative with C equal to 0. But of course, the f of x that I want, I'll assign f of x. So the assign is the dot equals. It's the same as define or store. It's going to be this answer here plus C, because I know that I don't want C equal to 0. Now, I need to solve for the particular case. So if I go to the algebra and solve, I want to solve for f of, now when x is -1, my y value is -5 on 2. And I need to solve that for C. So I find that C is 3/2. So if the question asks for f of x, then of course I can't just give the answer as 3/2. I need to make sure that I write plus 3/2. And that's f of x in this particular case. Okay, now to investigate what's going on a bit better, I've done the same thing again, except that this time I've graphed the antiderivative of f1 of x, which, as we saw, TI-Nspire returns the value with C equals 0, but I've also got plus C. And I have a slider where I can change the value of plus C. So as I change the value of C, see that I get a family of graphs. Of course, if I differentiate any of those graphs, I will get exactly the same gradient function shown in the blue. So for example, at x equals -1, we see that the gradient of the tangent is always 4. And that's why on the blue graph, you've got the point -1, 4. The gradient of the red graph is always 4 at x equals -1. And that illustrates why when you do an anti-differentiation, you have to include the plus C. There are infinitely many possible solutions. Okay, and lastly, we can set up a notes page. Now, a notes page allows you to do dynamic computation. So what we saw graphically in the other page, we can also do in a notes page. So in a notes page, if you want to do dynamic computation, you just have to insert a maths box. So once you're in a notes page, it's just menu, insert, and you see that you can insert a maths box, or you can see that the shortcut is just Control M. Of course, it's much easier. And once you've got the maths box, just escape out of there. Once you've got the maths box, the computation is dynamic. So as I change the value of C, I can see the values changing in the maths boxes. So the value that passes through negative 2.5 or negative 5 on 2 is when C equals 1.5. Okay, and that's the end of that activity.